coming up, we're going to have Abby and Philip talk to us about Earth observation data in the Oracle Cloud. We like to incorporate one thing in here. Abby, I heard, just to share a rumor, that you coach football over in the UK. I also heard that you actually are interested in, you have an offer to come out and teach and coach some American football. And come over here, just like Ted Lasso, right?
Yeah, 100%. I'm game for giving American football some. That's a weird shaped ball, right? That's the one with the sticks and the weird shaped ball. No, the soccer, 100%. I'm there, Dan. I'll definitely do.
Oh, okay.
Maybe we can incorporate that in the conference. I'll do like a five-a-side competition. We can get everyone doing a bit of exercise during the conference.
Right. And so also, I had heard that, Phil, you have a little known fact is that you have a photo business, correct?
Yeah, I do. It was something I set up January 2021, mainly to pass the time during lockdown with COVID, getting out and about with the camera, and then just set it up from there. So it's just been blossoming on the side, really. All landscapes from around the northeast of England in the UK.
Sounds wonderful. Well, with that, let me go ahead and just turn this over to Abby and Phil. We're interested in hearing you talk about Earth observation data in the Oracle Cloud. Go ahead and take it away.
Thanks, Dan. Everyone, great to be with you, and fantastic to have you here. I did notice in Q&A a few people saying the chat was not working. I believe Carrie in the background has worked her magic and it is now working. So yeah, we encourage you, ask us questions, say hi to your friends, drop us a line on where you're dialing in from. We'd love to hear more about you. So without further ado, we've had the intros. I'm Abby. I'm the Chief Technical and Data Science Officer at Vertice. Background, I have a PhD in artificial intelligence. Like all good PhD people, didn't know what to do with myself afterwards, and went and became a junior database administrator in Oracle technology, as you do after a PhD. But now I am Chief Technical and Data Science Officer, so I'm bringing together that good DBA skills with joining it up with the AI and machine learning. I'm joined by Phil. Phil, nice to see you again.
Yeah, morning, afternoon, good evening to everyone joining from all over the world. So my name is Phil Godfrey and I'm a senior data science consultant at Vertice. So my background is very much in data science. So I was at the UK NHS Business Services Authority for around 6 years in that role. And prior to that was involved in finance systems development. So I have a mix of knowledge, all focused around Oracle, which is kind of fitting to the presentation today. Really, we'll go around the full Oracle stack, taking you on a journey on Earth observation data.
And if anyone's interested, that is actually one of Phil's photos there. So there you go. He really does have a photography business. Very quickly, Vertice, we are a Oracle expert services. We've been in the business since 2010. We're very much about working with the community and exploring how we can get the most from Oracle technology. And we're very much into the autonomous database as well as Oracle Cloud. So without further ado, let's get into this.
Yeah, so for data science, as any other delivery service, we want to focus on how do we best get the best outcome based on our data. So everything starts with a problem or an opportunity, which is that business problem at the top. We then go and fetch some data if we don't have it already. On that, we'll perform some analytics, which will generate some insights, which the key point here is at this point, we will generate some actions to go away and do something, or call to action, which will then create an outcome or an output. But basically, it's all really with a business problem at the heart of the main question, and this is exactly the same. And what we want to do is to follow the CRISP DM method, which is the cross-industry standard process for data mining for delivery. So the aim of this session really is to kind of understand how can we explore and work with Earth observation data in Oracle Cloud. So by the end of this presentation, what I'm hoping is that you could effectively have the world at your feet in OAC, in analytical sense, of course. So for those of you that don't know, to just give a very brief overview of what Earth observation data is, it's basically data that is used to monitor and assess the status of the Earth. And that is used by gathering observations of the Earth's surface and atmosphere via remote sensing instruments. So remote sensing is basically gathering information about an object without making physical contact. So with that in mind, it's usually acquired in the form of digital imagery. And what can we use Earth observation data for? We actually use it daily and probably don't even realize. So things like forecasting weather is used using Earth observation data. We can use it to monitor and respond to natural disasters, including fires, floods, earthquakes, and tsunamis. We can use it to track biodiversity and wildlife trends. And we can use it to predict and adapt to and mitigate climate change. So there's various use cases, which is why for myself and Abby, it was kind of a key topic to try and tap into in OAC. So how is it captured? So I mentioned it was via remote sensing, and there's various ways that we can do this. Typically with Earth observation, you instantly go to space to think, right, it must be from there, but that isn't actually the case. So the main platforms to collect this information is either from a drone or aerial or via a satellite. So both of these have various advantages and disadvantages. If we think of a drone, it's got a high level of detail and a high spatial resolution because we can move it at a variety of different angles. I'm sure you'll have all seen drones are really popular now in wedding photography. So you'll see them flying around all over the place. The disadvantages is it's got really low coverage because it's quite close to the ground. If we look at satellites, they have a much higher coverage because they're much higher up and away from the ground. And this provides the ability to do some time series analysis because you can track this over a period of time. I guess the disadvantage here is that there's a lower level of detail because it's further away from the ground and also can be very costly. And some recent examples of satellite imagery, there was a dust storm in Iraq taken in April 2022, which you can see on the right-hand side there, which turned the skies orange, which reduced visibility and degraded air quality. And a second example was a nano satellite to get a bird's eye view of the sediment and plankton near the Strait of Dover. So we get to see fairly quickly that you can get really high resolution images depending what type of satellite you use. If we just go to the next slide.
So really, where does this all fit in with the Oracle Cloud? Obviously cloud, very much in these satellite images, but we're actually talking about the Oracle Cloud, so the non-fluffy type. Well, what we wanted to do was look at the various technologies, and we'll literally be taking an around the world trip of the Oracle technology. So our journey is going to begin in the autonomous database, so storing the data. So we've got those images from the satellite and we're going to bring them into an ADW, so it's store of the data. Then we're going to explore the data in the Oracle Data Science platform. And really here we're using the world of Python and open source technology to explore those images, to potentially classify those images. And then we want to save any of our modeling and ML results back into the ADW. But that's one part of the story. Really, as Phil said, is putting the business back into the middle of this process. So really what we want to do is enable the business to utilize that information and to be able to do actions, you know, to take that insight and action it and hopefully drive outcomes within the business. So what we're going to show you is how we can then bring that data from the ADW into the OAC and make sure everybody can access it and use it in the most appropriate way. So first one, business problem. We've kind of touched upon this. And in this case, what we're going to do is create a machine learning model that, given an image, you can basically predict what that image is. So the one on the left-hand side, what we're essentially doing is saying, is that annual crop? Is it a forest? Is it a highway? Is it a river? Is it a sea lake? Now, some of you are probably looking at that image going, I'm a bit torn between highway and river. So Phil, it's fair to say, pretty tricky image.
It is indeed.
Yeah. So what we're going to start with is loading these in, and what we've done is we've got an expert to label them and put them into one of these categories. And the business problem is, if we were to show it images in the future, could it classify the images for us so that, you know, the experts can move on to another area? So that's kind of the business problem. So data. Phil, where have we got this one from?
Yep. So we just jump to the next slide. So for the purpose of the demo, we're actually going to be working with some freely available data. I don't know about you, Abby, but I only like free data. I don't like paid for anything.
Yeah, for demos, we definitely like free data.
Oh yeah. So we've accessed this from Kaggle. So I don't know if any of you guys in the user group have accessed Kaggle before. If not, I would definitely recommend. There's so many data sets that are available. But for this demo, what we've done is we've utilized the Eurosat data set, which contains 27,000 images from a Sentinel-2 satellite. And this relates to those 10 different types of images that Abby alluded to on the last slide. And there's two options really to load this into the ADW. We can either download the data. It's 2 gigs, so it's not too huge. We could load that as a CSV using the data load utility, or we can utilize the Kaggle API within Oracle Data Science.
So let's get into some analytics then. So this is where we start to move away from just the standard Oracle database. Everybody knows the ADW and the Oracle database, and that's what it's known for. Where we're going to go now is we're going to go into the Oracle Data Science platform. So if you're a Python user, you're going to start to see this on screen and see some similarities to the Jupyter Notebook environment. And it really is very, very similar to that. It's just got an Oracle wrapper around it. The first step of any Python script is you import your packages. So some ones to just highlight on this screen is cx_oracle is going to create your connection to the ADW database. Now, there are a couple of ways you can do that, and we're going to touch on one of them. Depending what your security model is within your organization will depend on how you use that cx_oracle. We've also got pandas for data manipulation, so looking at row and column-based accessing the data, manipulating the data, formatting it, etc., and TensorFlow for our machine learning. So connecting to the ADW, always the first step, and as Phil said, you could use the Oracle Data Science platform and the API to essentially store the data into the ADW. And what we mean by that is, here on the right hand side, the first step we say is, where is the database wallet? So for the ADW, we've downloaded the wallet, we've saved it into the Oracle cloud, into the Oracle Data Science area, and we give the TNS admin the link to where that wallet is. The next step is providing a username, password, and your database name. So your database name is coming from your wallet and will be connected to high, medium, low access of the database. Once we've done that, we can ask the Python just to say, yeah, I've successfully connected to that database and we're good to go. Now, assume you've already got the data in there. So we've not used the API. We've done it through the data load in ADW. So we've got 27,000 images in there. So the next step is to start looking at these images and seeing what they are. So on the right-hand side there, you can see that I'm starting to access that. And the reason you can see that I'm getting those objects through is cx_oracle.lob. So it's an object from there. And that's because each image has been stored into the database as a blob. Each time we pull a blob, we need to change it into an image file. So we open it and change it to an image file so that Python can recognize it. So you've got blobs in the database and image files in Python. So let's see what we've got. So on the right hand side, you can see that I've pulled out some of these, the training set, and what I've done is underneath, I've kind of put what classification, sorry, above it, I've put what classification. So you can see hibiscus, you can see pasture, sea lake, industrial, highway, etc. So we can start to see what these images look like. The other thing we might want to do is look at how many images we've got for each type. So what we're looking now is, are there any biases in the data set? Is it well represented in each of the categories? And we can see that, roughly speaking, they are all equally represented. The only one to observe is that pasture's got slightly less images than the others. But overall, not a bad selection of data. So we're happy that the distribution of that data is good, and we can move to the insights or the machine learning. Over to you, Phil.
Thanks, Abby. So, like any machine learning model, what we need to do is to split our data up. So we'll have a training, a validation, and a test set. And what we want to do here is effectively make sure that because our model's learning from historical data, we want to use our training data to train the model, but we also need to test this model to understand how well performing our machine learning model actually is. So what Abby mentioned at the beginning, we've had an expert go away and classify all of these images to say, this image we think is a river, this image we think is a sea lake, and so on and so on. And then what we're going to do is split these into 3 different data sets, and then utilize our test data set to work out our accuracy of our machine learning model. So the first thing we want to do is to create this model and train it. So we compile this machine learning model with that first piece of code, and this learns from our training and validation data sets. So it runs through epochs. We run through several iterations of this, and then what that allows us to do is we can evaluate the model to understand the accuracy. And it's almost 97%, which is pretty good. I would be concerned if it was any higher than that, if it was around 98, 99, 100%. Definitely red flags if it's 100% because I've done something wrong, if that's the case.
Yeah. Always good to check if you're getting up to 100% in modeling. You've probably got an overfitting model. So yeah, probably a top tip from myself and Phil is if someone brought to you a machine learning model with 100% accuracy, I'd probably ask them to just go away and maybe have another look at that model.
So what we can do to try and understand how well our models performed is to utilize a confusion matrix. I'm sure most of you will have seen these on before from previous machine learning models, but the way this works is effectively compares our predictions versus the actual results. So we can see across the bottom of the screen, we've got the predictions for each of these use cases. On the left-hand side, we've got the label of what it actually was labeled as. And we can see that blue diagonal is where we'd expect most of our data to be. So we can see that, we might predict its annual crop, and we can see that we have a high volume that actually was annual crop. So where we really want to get the most benefit from this is we can easily eyeball those use cases that don't quite fit in. So we can see we've got quite a few there, which we'd predicted as herbaceous vegetation, but are actually labeled as permanent crop. So what we might want to do is to go back into our training data or look at a selection of those images to see, is there a reason why that, they're very similar? Can we do some additional training, or can we resample? All of those kind of options, but it's a nice visual way to quickly understand where your model is performing well, but really where it isn't performing well, most importantly.
Yeah.
A nice little tip, which I came across for doing this, which is massively helpful. So one of the good things you can do is we can load previously created models. So we can see in that orange box on the screen there, we've got one line of code which effectively loads a model for us. And this is great because when we were running through this, I think it took 6 hours, was that, Abby?
Something like 6 hours, the first run.
Yeah, so what I want to do is to be able to save and reload this model. I don't want to come in every day and have to rerun the same analysis over and over again. So what we can do is we can save these models, load them, and reuse them every time. And we can do that using a single line of code. So what we'll do is we'll use this to classify one of the images in the ADW.
So now we've got our machine learning model. So Phil's taken us through that training and validation step. So the first 2 of those areas. So he's gone away, trained it, got the epochs, got a 97% accuracy. He's done evaluation on that model. He's verified that, yes, there are some categories that maybe we're not performing as well, but it's passed the business's tick box and said, yes, that's a good model. We'd like to start getting some actions from it. So what we want to do is apply that machine learning to other images in the ADW that have not been labeled by our training. So these are ones that we've kept away from our trainer, from our experts who haven't labeled them, and we want to apply the machine learning model and see what they come out with. So essentially we take an image in and we then do a model prediction. And that prediction, then you can see it's saying 000000001. So we get the class names, and we would be able to then apply those class names and see which one it predicts it as. So here's your image. We get this, and then we say this image is most likely belongs to river. And then what it also does is provide us a percentage confidence. So with 23.2% confidence that this is a river. So although that's pretty low, what we have to think about is that in this case, it's not as simple as true, false, or if you've seen other presentations I do, I talk about fraud or not fraud, where it's binary. So you will get higher percentages. We've got 10 categories that we could essentially fall into. So the category with the highest score, 23%, is the river, which is why it's come out with that one. The other 9 possible outcomes came out at 8.53. So it's 3 times more likely that this image is a river. So things to improve and we can look at, but it's also good to know that when we write the results back to the ADW. So essentially what we're going to do is end up with a results table that has the image ID, what category we think it is, so river, and what percentage confidence that has. So what we do, we end up writing this back as a predictive class. So we get the river, we get the predictive score, 23.2. And here you can see that I'm insert into image results. So that's a table within our ADW, image ID, prediction class, so river, prediction score, 23.2. And these values are the Python values. So ID, pred class, and then pred score. We close the connection after we've inserted it and we commit it into the database. Easy as that. So every time we see an image, we can apply the model, get its predicted class, its score, and apply the results in the database. Good job. We can check that in the database now by doing a select image ID and the pred scores. And what you can see there is I've joined it with a little join for the original image. So we get the image ID, the icon, so the blob, the image itself, the pred class, river, and this pred score of 23.2. Once that's done, we need to get the outcomes to the business. So Phil, over to you for OAC.
Thanks, Abby. So as we mentioned at the beginning, really what we want to do is to bring this back full circle to the business users for them to go and action and work with this output. So what we need to do is, first of all, in order to see this result, we need to use a little plugin within the Oracle Analytics. And this is in order to display the image so we can actually see what it is. And we can do so using a base64 image plugin, which is in the orange square on the right-hand side there. And then what we can do is we can create a canvas in Oracle Analytics Cloud for an end user to then work with. So what we've done here is create a nice little visual of how this could work. So we can click on an image. We can filter on that predicted class. So we might want to look at river. We can then go to the predicted score and filter based on our level of confidence. So we might say, I want to see those that are 50% or more confident that it's a river. We can do the same for residential. So we can look at a different type of image. We'll return all of these results that our model predicted as residential. And we can then play around with those scores to identify which ones that we're most confident in. And I suppose this is where you come back to your business logic. So Abby might be quite happy that an image which is 23% or higher is a river. But the business might be like, well, hang on, we actually really are only interested in those that are 90% confident. And this is where we can play around with our predicted scores to apply that business logic to cut out the images that we're not interested in and focus on those that we are interested in.
So why are we getting interested in EO data, and why are we trying to get you excited about EO data? So really the possibilities of EO data and what you can do is endless, and we wanted to provide you some useful links. So if you've watched this presentation and you think, actually, there's really some value in that Earth observation data, how can I get more? There's some examples here in Kaggle, so the Eurosat data set that we used, Sentinel Hub, you could sign up and start to explore the Sentinel Hub data. NASA, classic for our US audience, go and have a look at some EO data from them. And if you want to get more into what are the types of satellites, then there's the Intro to Earth Observation and EO data on the right-hand side. But why did we get into it? Well, this is because we are part of a project called Cameo. So Cameo is based here in Ireland. So both myself and Phil work for a company in Ireland. We're not in Ireland, we're in the UK, but as part of our business, we look at projects with Oracle Research and the University College Dublin. So we're looking at how Earth observation data can be used, how we can get more people involved in Earth observation, so understanding it and what its use cases are. But we're also looking at different use cases in terms of things like climate change, so looking to train models to identify things like dolphins. Where are dolphins migrating to in the world, and can that help us understand changes in sea temperature? Other examples are things like oil, and looking at oil pipelines, looking at where it is in the world, through to things like traffic, and how much traffic is on the roads and things like that. So you can see that through that Earth observation data, there is actually quite a lot of different areas you can get involved in. And thanks to Oracle for Research, we're able to do this with the University College Dublin and look at the usage of it and how it can be brought to the world in technology such as Oracle Analytics Cloud. So that's it for us today. We're going to hang around and answer some questions. Hopefully you've got some good ones for us. I will open up the Q&A now.
Abby, we did have one come in while you guys were talking, and one of them was, can we as regular consumers of data get access to satellite images to see the number of cars, for instance, in a parking lot at various times of day? That was interested in the melding of the satellite images and the drone images, and Oracle likes to do their parking lot demo in OAC. Is that real? I mean, can we really do that with the satellite images, or it's just too hard to get?
So the satellite images, it will depend on which satellites. It's not too hard to get. There are some that are lower down in orbit that allow you to get into that granular level of detail. Some of them are in the higher orbit, so you're looking at a larger space, and we're looking at then things like deforestation and looking at how much has been cut down and things like that. So the different satellites, different jobs, different kind of granularity, so picking the right satellite for the right job, it is available to you. So the links that we provided during the presentation, you can go in as a free user and explore this Earth observation data. If you want to get into what we've done today, using things like Oracle free data, so open data by Oracle, they've got lots of satellite images that you can bring into an ADW. Kaggle's another option where we showed off this one. So really have a play with it and have a go. In terms of, are there cars in a car parking lot?
Yeah.
Some of you may have seen the new Oracle visual service where it's a pre-built Python packages or machine learning models that look at images and detect objects. So things like cars being a classic. So you could just use that within OAC and it would be a lot easier. If you're doing things like we are, where we're looking at, can we reduce cloud cover? Can we predict things like deforestation? Can we find a dolphin in the sea? They're very unique machine learning models. So we can't use the visual service that Oracle have. because we're building very bespoke machine learning models for this project.
Yeah, another point just to add in there, if you do go down the satellite imagery route, just a word of caution that one type of satellite will use cloud cover, another will not. So as an example, if you look at the same parking lot over a period of time, you may have some images that are completely cloudy. I don't know what the US is like at the moment, but it's quite cloudy here today. So you may have some images which are completely cloudy, which you just can't use. So you can use a different type of satellite which isn't impacted by cloud cover at all. So you could get cleaner images that way.
They actually see through the clouds?
They're lower down in orbit, and some of them have special algorithms that are able to reduce out the cloud noise in an image. Pretty cool. I think, Dan, that just means that you want us back for part 2 to tell you how we do cloud cover.
Yeah,
right?
yeah, interesting. All right, another question came in, if you don't mind. Validation phase, and by the way, folks, continue posting stuff in there, and also we do have, I think now, chat working if you wanted to say hello to people. But from another person, validation phase after training phase in ML, is that necessary? What will be the data for that phase?
Okay, so in this case, we had a training data set and a test data set. When you download it from Kaggle, you actually have a training data set and a test data set. So because we were playing around with some of the different visual techniques and some of the different TensorFlow algorithms for object detection and things like that, we looked at things like neural networks versus random forest and things like that. So there's different models that you can use. But to enable us to have a, if you like, a consistent test set that is actually labeled, so we could do the confusion matrix afterwards, we essentially take the training data set and split it into training and validation. So the validation doesn't get used in the training, but enables us to have a consistent data set to do the confusion matrix on, to say how well the model is doing or not doing. When you see the last step where I take the river image, that's in the test data set from Kaggle. So it doesn't have a label next to it saying whether it is a river or not. That's completely unlabeled data, and I apply the model to it to label the data. So that's why we end up with a training, a validation, and a test data set.
Okay, another one came in. Would it also be possible to embed your Python code within the OAC data flow rather than use the Oracle Data Science?
Yeah, it is possible once you've built the model to house the model within OAC and use it as a data flow to do that step. I guess both myself and Phil are very much into the Python environment, so we were very much doing this in the Oracle Data Science platform and kind of seeing how much we could do in there and using the ADW to store it. Of the 27,000 images that obviously we used for the training and validation, we had another 17,000 where it was unlabeled. So, you know, these within the test data set. And I guess for me, because I wanted to do it on bulk, it was part of an ELT process. In the Oracle Data Science platform, it meant I could run through them very quickly, whereas in OAC, it'd be image by image by image. In the data flow, it's using the right tool at the right time for the right job. So play around with it, see what's best for your environment, but it is completely possible to put that machine learning model into OAC.
Okay, super. I'll encourage people, if you have other questions, post them up. We have just a couple minutes left before we go to our next presentation. I'll also share that the slides are being shared. They're posted up on the AMD OUC Slack workspace. So check that out to grab the slides from that. We'll post the link to that in the chat here. So you make sure you guys know how to join our Slack workspace. We'll give another chance for any other questions to come in as people are making their way through this. Oh, here's another one that came in. What percentage would you recommend to be used for training and test? How much do you hold out?
Oh, so a lot of people go by the 60-20-20 rule. So 60% training, 20 for validation, 20 for test. Go back to the first point where I said we looked at the data to see if it was well distributed. So when we were looking at the training data, if we'd seen that there was a very low proportion of images in one of those categories, that would have changed our train validation test strategy. And you may look at k-folds and things like that to balance your data sets, or upsampling, undersampling, etc. You really need to know your data before you choose the right kind of sizing for train, validation, and test. So get to know your data, play with it, explore it, understand it, and then choose your splits based on your data. Yes, there's a general rule of thumb, 60-20-20. You'll speak to someone else and they'll probably give you different numbers. But really, for me, it's always driven by what does your data look like and what's appropriate for your data.
Okay, super. Well, thank you so much, Abby and Philip, for sharing that. Very interesting. And we are recording this session, just so everybody knows. Those will be available. It may take a week or two for those to get chopped up and available on our YouTube channel. Otherwise, you can find them in the same registration link for the entire session, hopefully soon. But thank you very much for sharing that with us. We're going to go on to other presentations. We go directly in, and then we'll have a break after the next session.